Hi all, welcome to my YouTube channel Know About Embedded System. In this video, I'll be discussing about two important things. One is a RISC and one is a CISC processor. CISC, full form of CISC. CISC stands for Complex Instruction Set Computer. Name itself says the CISC, Complex Instruction Set Computer. What are the features? So whatever I told already, the same features here you can see. So what it says, the first point says that the processors will have a large set of complex instructions that can accomplish varieties of tasks within a single cycle. That is what I told. DSP applications, signal processing applications, your laptops, all are coming under CISC processes. The processors will have large complex instructions and that can able to perform multiple tasks in a single cycle. Okay, and second point, if you observe here, the CISC processors will vary its bits. Some CISC processors are classified as a 16-bit, some processors 32-bit, and some processors also 64 bits. So all varieties we will get in the industry. So based on again as an application, if you're working with a normal simple application, we'll go for 16-bit CISC processor. If you're having a very complex application, then we'll go for 64-bit applications, 64-bit CISC processors. That is based on the complexity. Next point, if you see here, the instructions may take more than single cycle to execute. So single cycle means, so it will take group of clocks. Just you can understand as of now, single cycle may take more than single cycle. That means it may take 2 cycles, 3 cycles, and 4 cycles like that. The CISC processors will, because you will be deploying your processor in a very complex environment. That is why it may take more than single cycle. It may take 2 or 3 and so on like that. The next point, if you see here, the number of instructions are more. This is what even I have told earlier. Number of instructions are more because you are deploying your processor in a complex environment, and we need to do the different types of processing. For that processing, we need a different types of complex instructions and variable in size, right? That's what. The next point, if you see here, complex addressing modes. The processors will have complex addressing modes. What is addressing mode? Maybe I will be covering in the next one of the video in future. So more number of addressing modes and more data types. So data types you can understand very easily. And will have less registers. More number of addressing modes, more number of data types, and less number of general purpose registers. Okay, and operations will be performed directly in memory. So in CISC processors, directly we can handle memory directly without any intervention. Okay, and CISC type of processors can handle all type of operation, register to register, register to memory, or memory to any type of operations the processors can handle. Data movement or processing anything. And examples for the CISC processors, I have listed very few here. So very important, I have listed 886 processor is a CISC processor. Motorola 68000 is a CISC processor. IBM processors 360 is a CISC processor. Intel 80486 is a CISC processor, and all AMD processors. All Intel and AMD processors what we're using in our laptops all are CISC processors, because they have to handle very complex instructions and complex operations. So this is all about a CISC. CISC means complex instruction set computer. I hope this is clear to all. Now in contrast to this, let us move to the RISC. RISC full form, already I told you, reduced instruction set architecture or reduced instruction set computer, you can say. So it's computer, it is. Reduced instruction set computer. What it says. So straightforward definition, and most of the instructions are straightforward. It's not much complicated, very straightforward definition. Now you can see here, reduced instruction set computer, simple instructions. Almost all instructions are very straightforward. Like I'll just give us few example here. Move or not, comma 1 2 3 4, and then add or not, comma 5 6 7 8, like this. These are all very straightforward instructions. Okay, and if you want to multiply or not, comma or 2, something like this. very straightforward definitions. So that is why RISC processors will have straightforward definitions and straightforward instruction. So next point, if you see here, the processor usually operates in 32-bit. So now if you compare the same thing with respect to CISC, CISC will have 16-bit, 32-bit and 64-bit. All possibilities it is possible in CISC, but in case of RISC it is 32-bit processors, 32-bit instructions. And third point, if you see here, the instruction will take single cycle. The same thing if you compare with the CISC will take more than one cycle, but RISC will take only single cycle. And in case of RISC, we will have more number of general purpose register. Even if you take example of our ARM processor is having totally 16 general purpose registers. Okay, so more number of general purpose registers you will see in case of RISC processors. And it can perform only register to register. The operation, if you compare with the operations, the RISC processor is able to operate between register to register. Okay. So, but same thing if you compare with the CISC, register to memory, memory to register, it is possible. Next point, if you see here, simple and less addressing, very simple addressing, straightforward, like direct, indirect, immediate, register to register, like that, very straightforward addressing modes, and fewer data types, very less addressing modes, and very less data types also you will see in case of RISC. Pipelining will be very easily we can achieve pipelining in case of RISC processors, but in case of CISC processor it is difficult to achieve pipelining, so we have to build additional hardware to achieve the pipelining. So what is pipelining? I have already one video, you can watch that. Maybe I'll add description, in the description I'll add the link. Okay, and RISC processor will execute faster because the instructions are very standard and lesser. The execution will be more faster and a low power consumption. So like this our RISC processes are classified. Okay, so just I want to add on one more point here. For RISC, I have shown you some of the examples like add, R0, comma 1 2 3 4, okay, and then move R5, comma like this, R0, something like this. So these are all the best examples of your RISC instructions. So when I say add, it's addition. Move, when I say it's movement of data. Okay, this type of instructions are called as RISC instructions. Very straightforward and simple. But one use case I want to explain with respect to CISC as well. CISC means you already know the definition. CISC stands for complex instruction set computer. So in this complex instruction, name itself says that it's a complex instruction set. So here I'll explain two different use cases here. DJNZ R0, comma loop 2. So what is the meaning of this DJNZ? So in this instruction there are two meanings. So DJNZ stands for decrement, jump, decrement R0 and jump to loop 2 if R0 is not equal to 0. If R0 is not 0. So this is the meaning. So why the CISC are called as complex? Because of this. So it looks like very simple, straightforward definition, but it is having two different meanings here. DJNZ R0, comma loop 2. So decrement R0, jump to loop 2 if R0 is not 0. So this type of instructions are called as CISC instructions, and CISC stands for complex instruction set computer. Okay, I hope the examples also are given for CISC and RISC as well, and I will move to the comparison. In the comparison, the CISC and RISC, you can see here, the RISC says that reduced instruction set computer, and CISC stands for complex instruction set computer. The CISC will be working 16 to 64. 16-bit, 32-bit, and 64-bit. RISC will operate in 32-bit mode always. Of course, there is a other thing called as thumb mode in ARM. That is a different case. So this offers hundreds of instructions with a different size, more number of instruction, but in case of RISC, very less instruction and straightforward instructions. And CISC architecture, which is designed for very high speed execution, very high speed and complex execution and complex execution, whereas RISC is designed for simple and straightforward instructions which will be executed in a single cycle. So chips are designed for complex design. That is what I told. These chips, RISC chips, are designed for a simple and straightforward design. Relatively little expensive compared to RISC. The CISCs are expensive. RISC will be less expensive. I have already given the example for CISC, and a RISC example you can see PowerPC, Spark, and even ARM is also coming under RISC. More number of instructions will be there in CISC and less number of instruction in case of RISC, and a variable length in the instruction in case of CISC, and almost all instructions will be fixed in case of RISC. And memory, you can directly operate at memory level. Memory using complex addressing modes. The instruction can interact with memory using complex instruction set, but simple addressing formats are used to interact with the memory. Directly, you cannot interact with memory with respect to RISC. You have to do some load and store architecture. So what is load and store? That I have in one video already. So that link also I'll put it in the description. You can watch that video as well. So this is a comparison between RISC and CISC, and I hope the video is clear to all RISC and CISC. So if you have any doubts and questions, you can just write to us. So in the comment section, you can write to us. We'll try to explain if you're not clear. Okay. So with this, I want to close my video. So if you're not subscribed my channel, please do subscribe and get notification and get more knowledge on embedded system.